Okay, so we need to talk a little bit about rotational symmetry. We've talked some about symmetry in the past. We just want to see if we can figure out what angle shapes have to be rotated by in order to go exactly back onto themselves. So for instance, if you start this star off the way it is and you've rotated it around the middle, by 360 degrees, it will come back on itself for sure. But are there any other angles that it can go by? For instance, what angle is this that would rotate one point just to the next point? And to figure out what that is, we just figure out that we have 5 points, and 360 divided by 5 gives me 72 degrees. So my angles are going to be multiples of 72 degrees. 72 degrees for 1 point over, 144 degrees to go 2 points over, 216 degrees to go 3 points over. I'm just adding 72 each time. 288 to go 4 points over, and of course 360 to go 1 point over. The Canadian maple leaf doesn't have any rotational symmetry at all except for 360 degrees. Every object can be rotated 360 degrees and go back on itself. The baseball can of course go 360 degrees and rotate back on itself, but also this point here could rotate around to this point, so it could also go 180 degrees. The sand dollar depends how you look at it. If you just look at the markings on the inside, then it's kind of like the star and would do all of those same angles. But if you use the sand dollar as a whole, including all these little other markings on it, here and here and here and here and here, then there's no rotational symmetry except for 360 degrees. Same thing for the diamond. The only way to rotate it back on itself is to go a full 360 degrees. The football could be rotated 180 degrees and go back on itself. So pretty simple, just trying to figure out what angles of symmetry there are on objects. So now I want you to try it on these shapes in your packet.